Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. For today, our group will present about van der Waals force. Let's go. Okay, for the history, the force are named for the Dutch physicist Johannes Frederik van der Waals, who in 1873 first postulated this intermolecular force. Okay, this image is the image of Johannes Frederik van der Waals.
What is van der Waals? Van der Waals is the bonding of an atom or molecule that electrically neutral and possesses electron configuration characteristic of inert gases. Van der Waals forces are weak forces that contribute to intermolecular bonding between molecules. Van der Waals forces are the sum of attractive and repulsive electrical forces between atoms and molecules. They are known rapidly to vanish when distance between interacting molecules increase. Because of fixed distribution of electric charge in the same molecule, one side of molecule is always positive and the opposite side is negative. The tendency of such permanent dipoles to align with each other result in net attractive force.
Okay, we continue to the formation of van der Waals. Okay, there are two formation of van der Waals. It is based on non-symmetrical charge distribution of crystal and interaction of electrical dipole. Okay, for the non-symmetrical charge distribution is about an electron charge distribution and interaction of electrical dipole about negative and positive side of the dipole. Okay, that's all.
Okay, so now we proceed to the next one, which is on characteristic of van der Waals. So first thing first, van der Waals are additive and cannot be saturated. So basically, they are weaker than either ionic or covalent chemical bonds, and they are not directional. So van der Waals work in a short range, which means that the interaction is increased when molecules are closer. So basically, they are independent of temperature, with the exception of dipole-dipole interactions.
Okay, next. So what is a dipole? Dipole, an electrical dipole, is formed by a pair of oppositely charged separated by a small distance, which is we call it as a D. Since the charge is not concentrated, an electrostatic field towards the neighbor's charge is generated. So you can see that from the diagram, which is it have a two charge, opposite charge, which is positive and negative, separated by a small distance, which is we call it as a D. Dipole moment formula is micro equal to charge particle times with the distance. So you guys will ask, what is a dipole moment, right? Okay. So dipole moment, I can give you two examples, which is CO2 and H2O. Okay, it have two situations, which is no net dipole moment and have net dipole moment. So what when no net dipole moment? Okay, from CO2, oxygen is more electronegative than C. The direction will move to the higher electronegative because of opposite charge, opposite direction will cancel out each other. So you can see that the arrow from the C come out with opposite direction and it will cancel out each other. So that will have no net dipole moment. So when we have a net dipole moment, net direction of the electron movement towards oxygen by using Lewis dot structure. So it become polar molecule and have a dipole moment. So you can see that the arrow from the hydrogen comes toward the oxygen and it have a same direction, same sum vector, which is we call it a molecular dipole. So dipole moment is a net direction which is going towards up. Okay, next we go for the condition of dipole. It has two, which is inert and induced dipole. So what is an inert dipole? So for example, I give you two situations, which is for the first one, the symmetrical distribution of electron charge, and the for second one is an asymmetrical distribution, which is change with the time. So the first case, you can see that from the diagram, the electron in a static position due to no movement of particles. So you can see that the electron is a static condition, not move. Okay. For the second case, electron move to another side and produce unbalance of electron due to movement of particles. So when another particle come to this particle, which is asymmetrical distribution, okay, so the electron attract to the right side, okay, due to unbalanced electron and opposite charge. So you can see that the electron on the right side more than the left side. So that is an asymmetrical distribution.
Okay, for my part is inert gases of crystal. So inert gases have many characteristics. So one of them is transparent insulator. It have weakly bound. It have low melting point and have high ionization energy. So inert gases of crystal, outermost electron shell. So for the description, from halogen group, the outermost electron shells completely filled. They cannot bond, exchange, sharing electron, but little attraction due to different charge under condition pressure and temperature. Second, it have no interatomic force, which means it is weakly bond. Due to lower temperature, condensation of gases take place, but it will not be happen if no interatomic force.
Okay, we continue with induced dipole. Induced dipole means an ion or molecule that dipole induce atom or molecule that non-dipole, which is non-polar, to make a temporary dipole by disturbing the arrangement of a dipole. So this ion will make the electron that randomly moving to move to one side, and the positive charge will move to another side. So it become a temporary dipole. But the van der Waals force of induced dipole and dipole will be break when these two dipole and induced dipole distant from each other. For example, HCI, which is a dipole, will induce N2, which is a non-dipole, to make form a temporary van der Waals force. But it will break when these two will distant to each other. Okay, that's all.
At small separation, an overlap of the inner electronic shell starts to dominate. A strong repulsive force is generated. This repulsive force can be fit quite well by the potential of the form P over R power of 12, where B is a positive constant. The total potential energy of two atoms at separation R can be represented as the following equation.
So now we proceed to the next one, which is on Lennard-Jones potential. So basically, Lennard-Jones potential is a simple pair potential that can accurately model with van der Waals bonds between noble gases, yielding reliable bond energies and bond lengths. So basically, Lennard-Jones potential consists of two parts, which is set repulsive terms and smoother attractive term. So the attractive interaction is due to the temporary dipoles created by fluctuation of the electron cloud. And for the repulsive interaction, it is due to the overlap of the electron clouds, which forces electrons into high energy states. Okay, as you all can see in this graph, on the right side, which is on the smoother side of the graph, it is the attractive force, while on the left side, which is on the stick side, is for the repulsive forces.
So for the application of van der Waals, it is widely believed that geckos exploit van der Waals forces hanging on to smooth surface with only their toes. the attractive force that arises between the spatula of the gecko foot pads and the smooth surface enable the lizard to effectively climb this surface. Similar biological design can be observed in some spiders, which we can see in our daily life. Geckos either in the house or at the outside, which have a low friction force on the surface of the gecko's climb. It can climb easily because of the attractive force. So even though there's no friction, geckos also can climb the surface. That's all from us. Thank you.